Okay, welcome back. This is Mr. Hassan's Maths channel. I'm answering question number 7 from the June 2024 International A-Level Edexcel Mechanics M1 paper. The question is about vectors, and we're told that the horizontal unit vectors I and j are directed due east and due north respectively, and position vectors are given relative to a fixed origin O. So it's like when we're drawing the vectors, we'll draw j like this and I like that, and it's like we're looking from above, and this is north, east, south, west. Okay, we're looking from above, right? So it's like a plan view that we're going to be drawing. So it says two speedboats A and B are each moving with constant velocity. Okay, so they're both going with constant velocity. The velocity of A is 40 kilometers per hour due east, and the velocity of B is 20 kilometers per hour on a bearing of an angle alpha, and alpha is between 0 and 90 degrees, where tan alpha is 4/3. The boats are modeled as particles. Find in terms of I and j the velocity of B in kilometers per hour. So we should know that velocity is a vector quantity. Velocity has a magnitude. Okay, it has a magnitude. Let me spell it right. So velocity has a magnitude, and it also has a direction. Okay, so the magnitude of this velocity, the magnitude of velocity for B, okay, for B is 20. That's its speed. That's the speed that's going out. Okay, so that's the magnitude part. And the direction is given by this description over here. So the bearing of angle alpha. Okay, and alpha is between 0 and 90 degrees, and the tangent of alpha is 4/3. Okay, so the direction is angle alpha from the north line, from as we'll discuss in a minute. Okay, so now we're going to try to work out how we can write in terms of I and j the velocity of B. Okay, so in terms of the direction of B, it's been described in terms of a bearing. Now, bearings are measured always from the north line, okay, and they're always measured clockwise. Okay, so from the north line and clockwise. All right, so let me draw a line like this. So they're always drawn from the north line and always clockwise. So we're going to go clockwise, and the angle is between 0 and 90 degrees. So somewhere in this quadrant. Okay, somewhere in this first quadrant, somewhere pointing up this way. Okay, such that the tan of the angle is 4/3. Which angle? The angle between the north line and this line. The angle in a bearing is always measured from the north line clockwise. Okay, so from the north line clockwise means along this line over here somewhere, where this angle is alpha. And the tan of alpha is 4/3. Okay, so alpha is going to be an angle like this. It's going to be such that it's from the north line clockwise, and the side opposite alpha would be 4, and the side adjacent to alpha would be 3. So if I draw a little line like this, okay, and make a little right angle triangle here, this is 4 and this is 3. So the vector B, it's in the same direction as this. It's in the direction of this, and this vector, if you think about it, is in terms of a column vector, it's going to be 4, 3. Now that is not the velocity of B, that's the direction. That's the direction of B, not the velocity. Because if the velocity of B, then it has to have a magnitude of 20. Now this doesn't have a magnitude of 20. This has a magnitude of 5. If we look at this, it's a 3, 4, 5 triangle. The length of this line is 5. We want a vector which is going in the same direction, but we want it to have a magnitude of 20. So it has to be 4 times as long. Okay, it has to be 4 times as long. That would be the vector B, the velocity of B. So the velocity of B is going to be 4 times 4/3. Okay, so our vector, the velocity of B, is going to be 4 times okay, the vector for 3, which is 16, 12. That is a vector which has the same direction as our vector, as the velocity of b, and the same magnitude for 20 kilometers per hour. Okay, so therefore we can say in terms of I and j, the velocity of b, we should give it in terms how they say 16I plus 12j in kilometers per hour. Okay, so that's how we find the velocity. You have to be careful. It's not just the direction and it's not just the magnitude. It's a magnitude and direction. So this vector has to have the correct magnitude as well as the correct direction. Okay, so that's how we can deal with that. Some people might want to find the unit vector first for 4,3. And the unit vector of 4,3 is going to be its magnitude, which is 5. So you do 1/5 of 4,3. That's a unit vector in the same direction as b. That would be a unit vector in the direction of b, and therefore what we want is a vector which is 4 times as big as this. Okay, because it has to be, sorry, how many times as big as this? It has to be 20 times as big as this, because if we want a vector which is 20 kilometers, so it's to be 20 times 1/5. So this is one unit. We want 20 units. We want 20 times 1/5 of 4,3, which gives you the same answer, of course. That gives you 4 times 4 and 4 times 3. And got your answer. So there's how we find the velocity of b in kilometers per hour. So it's a kind of like a slightly different way of asking us to find the velocity of this boat. Okay, so at noon, which is at midday basically, the position vector of A is 20j. The position vector of B is 10I plus 5j. At time t hours after noon, the position vector of A is R, where R equals 20j plus 40ti, and the position vector of B is S kilometers. Find an expression in terms of t, for S in terms of t, I, and j. Okay, so the position vector of the position of a vector, so the position vector of S, they want us to, in general, it's R equals. I'll give you the general formula first. So R is the position vector of a particular object which is moving. R0 is its position when time is 0, the start of the journey, which in this case would be noon. Okay, its position at noon, plus V times T. V is its velocity vector, and T is the time. So in this case, they want us to find the position vector of B. So RB is being denoted by S. So S is equal to, we have R0, which is the position vector of B at noon, which is 10I plus 5j. So I'm going to write it in a column vector form first, 10I plus 5j, plus its velocity vector, which we know is 16I plus 12j, so 16 and 12, okay, times t. I'll put the t there, right? So that is a position vector of B. Okay, that's simple as that. We don't even need all of that space. Okay, that's position vector of B. But they want it in terms of t, I, and j. So we should write it as S equals 10I plus 5j plus t times 16I plus 12j. Okay, if you want to, you can write it as 10 plus 16ti plus and plus 5 plus 12tj. You can separate the I and j components if you want to. That's an alternative way of writing, so I'll write it like that as well. You can write it as 10 plus 16t I component plus 5 plus 12tj. So I and j component. Both of those are correct. Okay, now for part C, it says show that at time t hours after noon, the vector from A to B is given by 10 minus 24ti plus 12t minus 15j kilometers. So the vector from A to B, okay, can be found as follows. First of all, what we know is the vector from O to A. So let's do the pen, hold on. We know the vector from O to A. That is the vector that's, we call the vector from O to A is the position vector of A, which is R. Okay, so that's the position vector of A. When it says position vector, it means the vector from O to that point. And we know that that vector R is given by the vector as they told us, which was, where is it? 20j, position vector is 20j plus 40ti. 20j plus 40ti. So that's 20j plus 40ti. As a column vector, that would be 40t and 20, this 40ti plus 20j, basically. All right, that's the position vector of A. And the position vector of B, which is O to B, is given by the vector S. And the vector S, as we see here, is 10 plus 16ti and 5 plus 12tj. Now we want to go from A to B. So what we have here is O to A, and we also have the vector from O to B. So suppose this is O, and this is A, and this is B. Okay, so what we have here, this is O, this is A, and this is B. So we have O to A, which is our vector R, and we have O to B, which is our vector S, and we want to find the vector from A to B. It takes us from A to B, which is this vector over here, okay, which is what we're trying to find. What we can say is the vector from A to B, if you want to go from A to B, it's like minus R plus S, like minus R plus S. Going this way and then that way, which is the same as saying S minus R. So if we do S minus R, we have 10 plus 16t and 5 plus 12t minus 40t and 20. So that gives us 10 minus, well, there's no non-t term, it's going to be 10, and 16t minus 40t. So 40 minus 16 is 24. So minus 24, because it's 16t minus 40, so it's minus 24t. That's the I component. And the j component is 5 minus 20, which is negative 15, and 12, just plus 12t, there's no other t term, plus 12t. Okay, and that is our vector from A to B. This is from A to B, which we can express as in ij form as we're going to have 10 minus 24 ti and 12t minus 15, the one in that form, and 12t minus 15j. Okay, so there is A to B. Just about fit it in the bottom. I should have done it on the next page, but no problem. So we've shown how we found the vector from A to B. Okay, so that's something that tells us how to get from A to B. And now that's t hours afternoon. Now we've got to do part D. And now for part D, we're told to show that the boats will never collide. Now there's numerous ways of doing this question, but by far the simplest way of doing this is to basically understand that if they collide, then the vector from A to B is going to be equal to 0. If they collide, the vector A to B has to be 0. So that means that you got your 10 minus 24 ti and your 12t minus 15j has to be equal to 0, 0. So if the if the value of t that makes this 0 is the same value as t that makes that 0, they're going to collide. But if the value of t makes this 0 is different from the value of t that makes this 0, then they won't collide, because the values of t have to be the same for them to be in the same place at the same time. So if we solve this first equation, 10 minus 24t equals 0, then we have 10 equals 24t. So we end up with 10 over 24 is equal to t. So t is equal to 5 over 12. That's from the first equation. From the second equation, we get 12t minus 15 equals 0. This is from the i's, and this is from the j's. So you got 12t is equal to 15. T is equal to 15 over 12. So t is equal to 3 goes into this 5 over 4. Okay, so as, let's call this T1 and T2, as T1 and T2 are not the same, therefore they will never collide. They will never collide. That's one way, and probably the easiest way of doing it. We could also find the magnitude of the vector a to b by squaring this. So you have 10 minus 24 squared, 24t squared, plus 12t minus 15 squared. And we could find when the magnitude of this vector is equal to 0. Okay, we could then equate this to 0. They'll collide when the magnitude of the vector between a and b is 0. It means there's no distance between them. And then when we try to solve for t, you'll see that you won't get any solutions for t. It will give you no solutions. So you'll set up a quadratic equation, you'll find the discriminant is negative. So there's no solutions, meaning there's never going to be a time for which the distance between a and b is equal to 0. There'll always be a distance between them. That means they will never collide. Okay, that's another way that looks, as you can see, that's a lot more work than the way that I mentioned here. So you could do it that way, and that's perfectly fine. Okay, but that's going to take a long time. But that's how you would do it. You would end up with a quadratic, expanding the brackets. You'll end up with a quadratic equation, which you can then try to, you can show that there's no solution to that by using the discriminant. You find the discriminant is negative, therefore there's no solution. Therefore there's no value of t for which they will collide. This is easier. If they collide, they have to be in the same place at the same time. So the same time that the I components have to be 0, the difference between the I components, and basically because this vector tells you how to get from A to B. So if they collide, then how do you get from A to B? Well, you don't do anything. They're going to be at the same place at the same time, right? So if this vector and this, if this value of t for this being 0 and this value of t for this being 0 are the same, they'll be at that same place at the same time. And we can see they're not the same. Okay, they're not the same, therefore they'll never collide. That's part D. And now for part E, it says find the distance between the boats when the bearing of B from A is 225 degrees. So again, we have to understand our bearings. Now 225 sounds like something familiar. So this is our north line. Okay, and we got to go now clockwise, and we have to go clockwise. And here we are, clockwise through 225 degrees. That's 90 degrees. That's 180 degrees. That would be 270 degrees. Now, 225 degrees is exactly 45 degrees more than 180, exactly 45 degrees less than 270. So it's kind of like southwest. So they gave us a nice, easy angle to deal with. All right. So if we just draw these lines, we see that this is basically the angle we're considering. The bearing is from the north line clockwise. So that's 225 degrees, which means this angle here is 45 degrees because it's 180 minus 225 is 45, which means that this is the direction exactly southwest. Exactly southwest. So it's basically the I and J components are the same. Okay, the I and J components are the same, magnitude. So we can say that the I component 10 minus 24t and 12t minus 15. Okay, that's going to be in a direction which is the same direction as southwest. Okay, so it's going to be some constant times. You can say minus 1 minus 1. That's like minus 1 minus 1. Right? So basically, what's going to happen is you're going to end up with 10 minus 24t, okay, is equal to minus k, and 12t minus 15 is equal to minus k. So if we basically subtract these two, okay, equations from each other, okay, you're going to get your answer. So if I subtract these two equations, I'm going to have the 12 minus 24, which is 36t, minus 15 minus 10, which is minus 25, is equal to 0. So t is going to be 25 over 36. and that is in hours. Okay, kilometers per hour, I think we have. Yep. Okay. And therefore, it says, find the distance between the boats when the bearing. So now we know that the time is 25 over 36. So we need to find the magnitude of the vector from A to B when time is equal to 25 over 36. Okay. So we got to put this in the, this square root of 10 minus 24 times 25 over 36. That has to be squared. Plus, and you're going to have 12 times 25 over 36 minus 15 squared. And that will give us as our answer, just put it in a calculator, we're going to have the square root of 10 minus 24 times 25 over 36. Okay, squared plus 12 times 25 over 36 minus 15 all squared, and that gives you 20 root 2 over 3, 20 times root 2 over 3 kilometers, which is equal to 9.428 kilometers, which is 9.43 kilometers, to correct to 3 significant figures. Okay, so there's the answer to part E. And that concludes this question. This is question number 7 from the June 2024 International A-Level Mechanics 1 paper. Other questions from this paper can be found in the playlist that will appear in the top right of the screen at the end of this video. Other questions from the topic of vectors from M1 can be found in the video, the playlist, which is connected or linked at the bottom of the screen here. You can subscribe to the channel by clicking on this link, and the video that is linked above this space here will take you to, or will explain to you how to use my channel in a more efficient way. Thank you for watching, and see you